Welcome, everyone. This is the discussion section that follows the papers that we just saw. So I'm Erica Groshen. I'm at Cornell, and I was previously the commissioner of the Bureau of Labor Statistics. So these issues about how statistical agencies can protect privacy is hugely important because we are in the midst of this arms race between the protectors of privacy and those who seek to exploit data in ways that may not be beneficial. I want to thank all of the leaders of the Harvard Data Science Initiative, David and Francesca, certainly, but also Census, the Census team that's cooperated in this, the teams that produce the research, this really distinguished panel that you're about to hear from. What we're going to be talking about now is why and how is the census messing with our universe? Because the census, from a data point of view, is the universe that we refer to in so many ways. It is the population, right? It's used for allocating dollars, sample frames for weights, for validation. So in so many cases, so all of the private data users rely directly or indirectly on much of the information generated by the census, and certainly researchers do as well. And many data products from the US statistical system depend in one way or the other on the census also. So this is really a framing, a really important part of the public good that is our statistical system. So because of this arms race, the census has introduced a formal privacy regime known as differential privacy. And now many of us here are researchers. Where are we now, knowing that this is coming? And I would submit that at this point, we're not in a great place. We have, probably most researchers still have their heads in the sand. They may have heard this is coming, but they haven't really dealt with it. In addition, we have a few people who have been running around like their hair's on fire. So, right. We need to move beyond the head in sand or hair on fire reaction to helping Census to find the best way to protect privacy. And secondly, to prepare for the impact on all of the research that's going to be done going forward. How do we manage this change? So we have a really distinguished panel here from very diverse disciplines that's going to help us interpret what we've seen in session one. What have we learned? What are the new questions? I'm going to start off by allowing each of the panelists to talk for about 7 minutes each about their reactions. They've seen, they got copies of these slides before, so they're a little ahead of the people in this room. Then I'm going to ask them a few questions, and then there'll be time, extensive time for question and answer from the audience. So let me start with Cynthia Dwork, who is a computer scientist here at Harvard, and really was a leader in the movement, in the group that developed differential privacy, who really spearheaded its development. And so she's a great person to start off our conversation. Cynthia?
Okay. Okay. Good morning. Thank you very much, Erica, for this forming this panel, which I'm very excited to be part of and to hear from. I'm grateful to the authors, particularly of the Dwork and the Iphams and Upjohn studies, and also to A.B. Flaxman and Samantha Petty for sharing an early version of work quantifying the effects of the top-down algorithm. And I think that these studies give us a very, very valuable insight into the specific choices in top-down when applied to specific computations such as the dissimilarity index that are often employed. And I think this is a fantastic starting point for rethinking statistics and what should be computed moving forward. Now, I became interested in privacy from conversations with the philosopher Helen Nissenbaum, who at the time was investigating the question of what does privacy mean when you're in public and there are video surveillance cameras? What does privacy mean when so much about our activities can be pieced together? The question made as much sense in the online world as it did in the physical world. And the driving scenario for thinking through these definitions in the mathematical context was always the census. The census to me was analysis of the people's data to allocate the people's resources for the benefit of the people and with a legal mandate for privacy. To my mind, there was no more compelling scenario, and also in a situation in which that we are compelled to respond, privacy protection was even more valuable. So we always viewed privacy as a means of encouraging people to allow their data to be shared. Differential privacy's definition says that the risk of harm to you is essentially no worse should you choose to participate than should you choose to opt out. That was there from the very beginning, and this is even more important when the data can be compelled. Yes, you are forced to do this, but you will be protected. Now, the sources of auxiliary information from other than the data that are collected, have increased dramatically since those early days. And fortunately, the protections of differential privacy are unconditional. And therefore, participation is no more risky now than it was when these ideas were first developed. And the potential harms are severe. For example, discovery of the violations of Section 8 housing subsidized rental, housing, and also for other zoning violations. People who are the beneficiaries of Section 8 housing, which is always surveilled, and for which there's always a lot of extra information, can lose their housing and become homeless as a result of a privacy compromise, as a result of the wrong set of people, or too many people, or people not listed on the lease actually being in that place. And a government whose immigration and customs enforcement directorates have contracted with Palantir to find illegal aliens for deportation is certainly capable of contracting for Section 8 enforcement and for the political mileage, no less than for the money saved. Now, moving forward from the studies. First of all, privacy versus accuracy can sometimes be a false dichotomy. So it can be useful and helpful to expand the space of mitigations that we consider. So let's consider the allocation of funds that Quentin talked about. What if instead of worrying about the fact that you might be miscounting the number of children below the age of 18, you decided to keep the per child allocation but extend it to all children of ages 19 and under? So districts would very likely be getting as much money as they got before, some of them more, but almost nobody less. Why should we expect that there is no financial cost to ensuring privacy? Privacy is valuable. Why shouldn't we actually find ways of mitigating the problems and paying for it? We're in a fabulous position now to start understanding magnitudes of error. So when we first developed some of these technologies, we were really excited that the magnitude of the errors that we were adding were smaller than sampling errors. So what about going forward? Are these magnitudes, in fact, less than the coverage error? Are they maybe less than shifts in the population over a year? populations change. How do these things compare? How about comparing the IPUMS errors to the NHGIS numbers? How do these things compare? So I'm looking forward to seeing and understanding this sort of from end to end moving forward. And next, prioritization. So we need to find less sensitive and more robust methods for critical computations and to prioritize them for spending the budget. Much as was done already for the voting rights enforcement, trying to get populations right for voting rights enforcement decisions. But together with strong privacy guarantees and potential encouragement accordingly of getting people to take part, these might actually strengthen the basis for enforcing the Voting Rights Act rather than undermine it. And finally, I think it's really important to resist mission creep. This is something that started turning up in the differential privacy literature in 2010. The estimated citizenship bits that the Trump administration is requiring will need protection. They'll need privacy protection. And this will either happen by diverting precious privacy budget that was allocated by the Data Stewardship Executive Policy Committee for the things that Census was supposed to be doing, or requiring additional privacy loss beyond the budget. So resist mission creep. We need privacy to be better, maybe even better than the epsilon that's going to be set by the Census Bureau. And you have to remember, when you think about this accuracy versus utility question, what it is we're really up against.
Thank you, Cynthia. Next is Joseph Hotz, who is professor of economics at Duke.
Just move it forward. Oops.
The other direction.
Hang on. They're on a. Oh, there we go.
There you are.
Okay. Sorry about that. You're going to see throughout this, as you probably have already seen throughout the other days, that there's an overlap of comments that are being made, and I'll try to sort of speed up over some of the ones that Cynthia's already made, and I know that some will be made later. The perspective I come from, I'm not an expert in this area. There's a longer explanation of why I'm involved in this. It has to do with some committees that I'm on and chair that deal with, that have been confronted with the issue of differential privacy. But my real focus is, and I think this discussion is about looking forward. What's the consequences for the 2020 decennial public release data? There are other data sources which will possibly in the future be affected by differential privacy. The American Community Survey has been referenced already, and I guess there's potentially other ones. This issue doesn't go away at the Census Bureau with its various data products, but this is a focus on those set of issues. And secondly, this matter about sort of, can we improve the trade-offs? Can we possibly work on those? And there I'll make some comments, which sort of some thoughts about doing that. These are really useful. Oops. These are really useful studies, and we learned some things which oh, there it is. Sorry. We learned some things that we confirmed some things we already suspected, which is the matter is the issue here in the context of census data is the distortion consequences for when you look at sort of this minimal for more populated areas and or groups which represent a larger part of the population, and the issue is with respect to sparsely populated areas, rare subgroups, and the combination of those situations, right? We know that it has many implications, and many of them are different, sort of are real serious problems. So this is not to trivialize that I can come down with one, bullet point or 2 bullet points to tell you what this problem is. We also learned some things in this I did that I didn't know, but I should have thought of, and that's the consequences for in the report from NORC, right, about sort of this consequences for data collection, right, and sampling frames. A huge issue if you're at all involved in this world of sort of collecting data and starting with trying to develop sampling frames. This has become a big issue in the cost of surveys of whoever collects it, right, and that's a big issue. And then the last one is this matter about that Brad Hirschbein talked about, which is the difference between two different versions of so-called the truth of the data, as was indicated here by the PUMS and the National Historic Geographical Information System data. And the point I want to pick up on in this one, it really is a matter of different data give you different answers. This is not a new phenomena. If you look at any number of phenomena of, for example, one, I know something about the measurement of income. If you look at different data sources, you'll get different answers about sort of facets of the distribution of income and characteristics about things like inequality. Okay, so there's some things that I want to sort of put on the table, and again, some of these have already been covered, between these data sets. It would be useful to sort of, even if the Census Bureau's made decisions here, to sort of do some comparisons against alternative methods. What are the differences? And this is the beauty of the 1940 data, where you know the individuals applying different methods and asking that question. Now, this would be a useful kind of academic exercise. I think it would be a useful exercise in general. And one could consider alternative, sort of strategies for doing this, and I think that would be a useful thing to sort of consider. Secondly, and this has sort of come up in Brad Hirschbein's comments, right? There are a bunch of different sources of data distortion that occur, right? We know that people they misreport information, maybe less so in the 1940. Those were my parents, or our parents and grandparents, right? Not us. Maybe they were much more accurate than we were, but this happens, right? And it's going to happen more as data goes forward with respect to now a much more complex set of questions that are going to be asked about race and ethnicity that people will misreport or maybe not know what to report in these cases. We do, and I cite the work here of Don Ruobin and Rod Little, their book on imputation strategies for missing data. Some of that's missing, some of that's imputing, sort of dealing with the measurement error, missing data that may well happen again. Probably that didn't happen in 1940. Our forebears were much more conscientious than we were, or we will be. But that's a real issue. And my colleague Jerry Ryder at Duke is one who sort of keeps bugging me about this. We need to have a comparative assessment, and Cynthia made, at least I interpret the comment to make that. And the last one is about sort of the robustness of statistics. And I give the example here that papers kind of do the dissimilarity index, one comparative point, and this is really a point that Brad Hirschbein made in his presentation. We really need to sort of recognize, one, that these methods are sensitive to whatever source of data error occurs. And secondly, we've got to start more proactively thinking about, okay, so what methods can we use? What's the nature of the bias? Can we adjust for that bias? Can we use different methods? And in the segregation area, there are a long list of measures that have been out there. And it's really, I think, incumbent on us to recognize we may have to change some things. Notice that's true, that's always been there with respect to other data sources of data error. There is work done on sort of the robustness of these different measures to the other sources of data error, and we need to consider that going forward. Okay, so the last part of the talk, I want to talk about something with respect to privacy. This is a slide that sort of gets out the Census Bureau's twin objectives, and it's the source of the attention that is present. Their mission says they want to produce data that is valuable. That's not just for academic uses. I mean, if you look at the list of things which depend upon census data to run governments, to make decisions, I have a colleague who, in the city planning, for the city of New York, who worries about where is it that vulnerable populations live because they need to figure out at fine geography where to locate emergency equipment for the next hurricane or heat stations during, sort of heat waves. To the disclosure avoidance, which is covered by Title 13 in terms of the data disclosure, the pledge to citizens about the confidentiality of their data. One can have discussions about what exactly that covers, and I think there's debates about that, but what I really want to talk about is this issue, which is, look, this is a diagram, I borrowed this from John About, a paper that John did, right? This is the trade-off, right, between privacy and accuracy, privacy loss and data accuracy. And if you look at this, right, we know where most of us are data users, where we sit, right? We want more accurate data. And while we may be individually, it's the comment that somebody made earlier, right? It's somebody else's privacy that we're willing to give up. On the other end, right, data distributors have been in this situation recently in terms of a study, data that I collected, right? You're worried a lot about this pledge that you made to people in a consent form about the privacy. But the question really is, I think, where's the public? Where's the public on this trade-off? And another question is, well, is there something we can do to kind of improve that trade-off, right? Can we not, I don't mean by, deceiving them, but can we move, can we have a way of sort of figuring out a way of improving both their knowledge of the situation and the trade-off they're willing to make? So here's the notion. Right? We know the following is true, right? I start with the privacy paradox, which many of you are probably familiar with, right? This is if you ask surveys, I'm going to show you some results from the surveys on the next slide. People just, are very concerned about their privacy, and yet what they're willing to disclose online, on Facebook, et cetera, is, reveals a lot about individuals. So this is I say this, I make this point mainly to make the observation that it's not so easy to figure out where people really stand on this issue, right? Their behavior doesn't always reveal exactly where they're at. So we need to sort of figure out the willingness, so the way I characterize it as an economist is their willingness to accept greater disclosure risk. What's that willingness? What's that trade-off that they're willing to make? And secondly, could we change that by ways in which we might sort of provide them with certain types of protection? And I'm going to put protection in quotes. So the next example is an example I've cited some work I did, and that's the question about sort of looking at the consenting to participate in this case, health studies, to consent to provide personally identifiable information, such as, in two sensitive ones, income and health records. What we find in this study, I'm running out of time here, if we look at and try to estimate, elicit from people their willingness to consent to participate in this study. What we found is demographics demographics don't do a particularly good job of predicting who's willing to consent or not willing to consent, providing either health or income information. And just saying, the preamble that you put in a consent the consent form for a study, right, when you ask somebody to provide this information, that doesn't move it much either. Two things that worked, right? Two things which we found were highly correlated with willingness to consent. One, trust. So we did some measures of trust in institutions, vague as they may be. And secondly, greater knowledge and utilization of privacy protection schemes, even though they weren't necessarily all that related to the particular data that we were collecting. These weren't schemes about your health records. That leads me to my last slide. Can we do a better job? I think we can, of educating the public about the disclosure risks. Can we better learn, right, and possibly change the willingness to provide accurate information? Can we build trust in institutions? That's really going to be hard. These two graphs show you there's not a lot of trust right now in government. That's a general trust at the top part. It's at historic lows. And secondly, providing information in the context. These are both questions from the Pew Research Center that collected in surveys. As you can see, if it's big enough, the federal government is second from the bottom, right, in terms of this list, exceeded by cell phone companies, credit card companies, et cetera. So this is a difficult challenge, but nonetheless, it strikes me that both the research in this area and the need to do this, to start to, one, better inform people about the trade-off, and secondly, not just tell them about the privacy loss, but also the potential gain from the information, the data utility, if you will, of that information. Thank you.
Next, we have Ori Heffetz, also an economist from Cornell and the Hebrew University of Jerusalem.
So thank you for inviting me. Thank you for organizing. I'm an economist, so a social scientist. I'll try to highlight these aspects. I just want to start by saying this is, to me, this panel and this whole day is such an exciting opportunity as a data user who uses data for living and have been thinking a lot about privacy and about the normative implications of the privacy usability trade-off. These kind of discussions rarely happen. So just bringing everybody together and trying to talk about these big issues, big difficult issues, is a great opportunity, so thanks again. I'll say 4 things. The last one is I'll read from a quote that some people in the room may recognize. It's something that was written a decade ago by some of the pioneers of the differential privacy literature. But before, I'll make 3 points. So the first point is about the 3 studies we've seen. These are exactly the kind of studies we should be doing now and seeing now. I would love to see many more of them. They put the theoretical privacy usability trade-off in concrete numbers, and we can talk about these numbers. It's great to see distributions and to talk about the tails of the distributions and about specific statistics with specific data. So this is great. The second point I want to make is about the range of epsilons that we have been seeing in the 3 studies. To me, at least, the ranges felt a little off. So when you look at theoretical papers in differential privacy, the example that we like to see is epsilon of 0.1. 0.1 feels like a good level of privacy guarantee. I am probably likely to participate in something like 10 censuses over my lifetime, maybe 8 or 7, maybe I'm optimistic. But so now we're talking about 0.01 per census. That's very different from 0.25 to 8, which are the numbers we've seen. So it would be great to see and to talk about the implications of levels of epsilons that we think actually represent meaningful privacy guarantees. Now, I don't want to belittle, again, I started by saying this is a great moment, and to my understanding, differential privacy right now is the only game in town, and a great game at that. So I don't want to belittle that when I say I want to see the relevant ranges, but in a way, we woke up to a reality that we have, 1.9 billion data points, but we released, I forget how many times that statistics. So clearly we are not protecting privacy. And I feel like what we have been seeing here in the morning is exactly the right step. You take all these pieces of information that you had no control over and you didn't even know what was out there. And first of all, you put them in one big box behind provably unbreakable lock. So that's the first step. My claim about the epsilon is that the epsilons we've seen here are such that the box is actually pretty transparent. Now, hopefully with technology that will improve, we will find ways to make the box less and less transparent and more opaque. But the first step of putting everything behind the provably unbreakable lock is a huge step. So the last point I'm going to make is exactly about this trade-off between the privacy and accuracy that we've seen here. So the differential privacy notion is such that guarantees against a worst-case scenario. On the usability side, we have seen distributions. So we never talked about the worst-case scenario. The worst-case scenario could be terrible. We just said, look, the chance to be off by more than X is low enough. That's an asymmetry, and that's an asymmetry that has normative implications. So it is for society, I think Cynthia nicely brought up some of these issues, but it's ultimately for society to decide if the worst-case scenario guarantee on the privacy side justifies we don't even know what is the worst case on the usability side. We just know the distributions. The treatment is asymmetrical, and I think we need to do much more research to understand that. And ultimately, it is really for society to decide whether this is the right notion. And again, if this is now the only game in town due to technological constraints, so these are not normative considerations, but that's the best technology we have right now, then should the epsilon be 0.01 or should it be 8 or even 0.25? That's for society to decide. And to start this discussion, we probably also have to broaden the panel here to include philosophers and to include ethics people and just members of the public. So this is not a discussion for us, the professionals, definitely not the technical people to decide on. The last thing is I'm going to end with a quote that I fully agree with. As I said, I found it in a piece that was written a decade ago by some of the pioneers of this literature. So let me just increase it enough so I can actually read it. Okay, so some people here may smile in the room and also on the stage. But a decade ago, some of the pioneers of the literature, and again, I fully agree with, and I'll just end with that, wrote, yes, this research is incomplete. Yes, theorems of the following form seem frighteningly restrictive, and then there is a theorem that I'll save you. But how else can we find a starting point for understanding how to relax our worst case adversary protection? How else can we measure the effect of doing so? And what other technology permits one to prove such a claim? Thank you.
So next, Salil Vadhan, computer scientist, Harvard University.
Great. Thanks, Erica. Thanks, organizers. Thanks, everyone. It's great to be here, part of this discussion. I'm a computer scientist here at Harvard and work on the theory and practice of differential privacy, among other things, and often in collaboration with social scientists. Okay, so I have a few reactions to this morning. Many of them are repeating things that have been said, so I will try to just emphasize some of the points that could be brought out more strongly. As others have said, I think the kind of work that we saw in the earlier panel is really important, and we need much more of it to learn how data users can make the best use of differentially private releases, and second, to inform the unavoidable, difficult policy decisions about accuracy for what should be optimized. Let me elaborate on this unavoidable decisions part, which was talked about a bit today. And this comes as I think we first heard today from Michael Hawes from the fact that the vulnerabilities that we heard about in census data are real and unavoidable. That it is just a fundamental fact that you cannot milk a data set unboundedly for analysis and still have any meaningful privacy protection. All right? You release too many statistics too accurately, necessarily will compromise individual level data. This is known not just, at first it was a mathematical theorem by Dinur and Nissim from over 15 years ago, the database Reconstruction theorem, and that's what we heard about applied to census data this morning, but it's been applied in other contexts as well, and for different settings of too many and too accurate. There are different kinds of vulnerabilities that appear, what are called membership inference, detecting whether a target is part of a population that membership in might be sensitive. And that's been shown to be applicable in practice to releases of genomic data that the NIH used to put online, and also more recently to machine learning services that are made available by industry. So just to hammer this home with an example that you all haven't seen, the machine learning case. So it turned out about a year ago, if you put nonsense into Google Translate, like shown here, something that's not meaningful in Somali, what it would do is start spitting out passages from the Bible, verbatim. Okay, you may not be worried about this if it's passages from the Bible, but now machine learning models are being trained on people's data, on their emails, on their text messages. and imagine a translation system that starts spitting out someone's emails. Why does this happen, and what does it have to do with what we saw with Census? Well, that's not the intended purpose of the translation system, and the translation systems do work quite well, and they translate texts that they weren't part of their training data very well. But this translation is being done by a deep neural net with millions of parameters, and somehow all of these numbers, even though they seem to be averages over this very large training set, are, when you put them together, they are actually memorizing some of the training data. Okay, and that's the sense. It's a very similar phenomenon to what we saw with the database reconstruction applied to census data. And it's also what motivates companies like Google to work on differentially private and release code for differentially private methods of training deep nets. Okay, so what does this tell us? So we need some theory, some approach for knowing when have we calculated and released too much, too accurately. And right now, differential privacy is the only framework we know for reasoning about the accumulated risk, which can be very complicated and non-obvious when producing and releasing many statistics like this. And it also tells us, as we've heard, that difficult policy choices are unavoidable. Again, we can't unboundedly analyze and release arbitrary statistics on a data set, and so we have to make difficult choices about which ones to prioritize for accuracy or to release at all. And that's a thing that differential privacy forces us to confront, but it's unavoidable. And we can reason about it and have discussions like today about it, because a feature of differential privacy is that the methods, the algorithms that are used to protect the data and inject noise can be made completely transparent and public. All right, second, a point that was made, and Joe talked about it quite a bit. There always has been noise in data produced by Census for a number of different reasons. And we saw this chart in Brad Hirschbein's presentation this morning about the difference in population between the IPUMS data and the official county populations, NHGIS data, which look quite comparable or even larger in magnitude than some of the errors that were introduced for the purposes of privacy. One thing that we haven't seen so much of today, and Joe called for, is really thinking about what is the, we aren't able with traditional statistical disclosure avoidance to know what the effect of those methods were on the accuracy of the data, because those methods relied on being secret. And differential privacy allows us to have the kind of conversations that we are having today. Now, I understood from this morning, from Michael Hawes' talk, that it could be done on the 1940 data, but really the relevant question is not 1940 methods, but more recent disclosure avoidance methods, and if those were done more aggressively to protect against the kind of vulnerabilities that we've seen, again, it's database reconstruction, then what would be the effect on utility, okay? It has been noted a number of times that these traditional disclosure avoidance methods like swapping and especially count suppression do have a significant effect on analyses. Raj Chetty et al., who use census and IRS data to study economic mobility, have found that count-based suppression creates a bias in ways in the kinds of analyses they do that can't be easily identified or corrected ex post. And so they show how using the count-suppressed based data, a graph like this, association between teenage birth and two-parent share, the slope changes radically like that. Okay, and one would imagine a similar sort of thing would happen for some of the analyses we saw this morning. So when you worry about under-coverage for oversampling designs, count-based suppression could have a very similar effect on that. And also on the kinds of effects we were seeing with the similarity index being very sensitive to the small numbers. Okay, so Finally, the final point, which was also made, is it's kind of a challenge going forward to the community, to data scientists, the community of data users in interaction with statisticians and computer scientists, differential privacy researchers, to recognize that the standard off-the-shelf methods that people have used in the past to analyze census data may not be the best choices when applied to differentially private releases. And we need to use or develop methods that are more robust and account for or compensate for the noise in the data. And that's a good thing, not just because we see the noise for differential pricing, but also because of all of these other sources of noise that traditionally we haven't compensated for. And this is something that's been borne out in the research literature on differential privacy, where even for basic hypothesis testing or linear regression problems, the go-to method that you would use on non-differentially private method data is not necessarily the best choice for when working with differentially private data, and it is better to switch to using more robust methods.
So next is Ruobin Gong, statistician from Rutgers. Thank you.
Thank you, Erica. Thanks for the organizers for having me. It's a great honor to be here. I still remember the days when I was taking my first probability courses, and there was the concept of simple random sampling being introduced. And people would say things like, on the one hand, we have a simple random sample of size 40, and on the other hand, we have the census. And which one do you prefer? And by way of saying that is to mean that the census is taken as the ground truth. And it has been the case for me, until I know better. As Joe was arguing and Salil listed very, in detail for us, there are all sorts of these variabilities that are inherent in the census from the beginning and till now, whether or not we're doing differential privacy as a disclosure avoidance mechanism for it. So I wanted to thank the three teams that from Dwork, from IPSUM, and from Upjohn Institution to share their very valuable insight with us earlier this morning. And it was a lot of hard work that was done to put the potential impact of differential privacy on the 2020 census in very concrete terms, in numerical, quantifiable ways for us. And I think that is really the lesson that I was taking away from reading those studies, is that whenever we're trying to draw inference based on the census data, the differentially private census data, or really any census data, we should really pay attention to doing proper uncertainty quantification. And have proper listing and have uncertainty quantification. There are two things that I want to say. One is uncertainty quantification. What does that mean? Which is when we want to report a metric, when we want to report a point estimate, always do it with a standard deviation with an interval to accompany that, with a distribution, with a probabilistic statement. Nothing should be taken as verbatim. So we should always, when we do inference, quantify the amount of uncertainty that is attached to the estimates. That is also not enough. When it comes to differential privacy, what we also need to do is that now that we know there's this added layer of uncertainty that's injected into the data intentionally, we should also use the model and use the model, augment the model to account for that aspect of noise that was injected into the model. And that is the part where we'll ensure how we could, in fact, be drawing accurate inference, accurate in the sense of at least it's truthful to whatever the model specification there is. There may be a loss of accuracy, there may be a loss of statistical efficiency, but that is the price we pay for privacy, and that is all duly calculated and as it should be in there. I think the most wonderful thing I think about adopting differential privacy as the disclosure limitation mechanism is its transparency. And this is to be able to know the mechanism through which the uncertain noise was generated is really wonderful. It is what statisticians do for a living. Previously, to have to separate noise and signal apart, we have to guess what is a noise mechanism. We don't have to do that. It's written down in a piece of paper. It's up in GitHub, and everybody could just take a peek at what it is. And that is just the best, the dream kind of model fitting that statisticians could imagine. I wanted to give you an example, and I want to talk about this in concrete terms, in pictures. So I'm taking a very simple linear regression, as you might want to do in your own research. Suppose that we have x and y. These are two vector counts, so think of them as histogram taken from enumeration districts and so on. You wanted to look at the association between them. So a simple linear regression, beta 0 is the intercept, beta 1 is the slope. And we all know that doing ordinary least squares, we get consistent estimate, in fact, unbiased estimators, and we'll be able to, essentially that is to say that we have very good behaving estimators that will be going to the truth very quickly with a quantifiable amount of uncertainty depending on the sample size. So that is all well established. Now, however, with differential privacy, what it means is that for these x and y, which are perfect data, we're injecting noise on top of them to make them epsilon differential private. And what that means exactly is to say that we want to make sure that XTP and YDP that come out of the mechanism, the probability measure that it assigns onto the sample space versus the one that's original to X and Y, those are very close. They're close in the sense of being bounded by epsilon to the power of exponential epsilon and exponential negative epsilon. So you can see as epsilon, which is the privacy budget, goes down, we require the neighboring data sets to have almost identical probability distribution. That is to say, we cannot distinguish them from each other. And as the budget goes up, it says that we really have no constraint as to just perturbing the data set by one respondent, how that might change the distribution of these histograms. And in the particular case, there are many ways that you can realize epsilon differential privacy mechanism. The simplest is to add a Laplacian noise to that, and that would be the example that I'm taking to go through to illustrate my point here. And for those of you who are rusty with your statistics, those are the two. The red one is a Laplacian noise, so that is the noise that would be injected onto the raw data, and this one that's depicted has a variance of 1, and it has an epsilon that's equivalent to square root of 2, which is 1.4 something, which is obviously too large to some of our standards. So here's the thing. Suppose that we do, instead of having the raw data and observe the differentially private data, and we fit the ordinary least squares to that, ignoring the fact that they were actually perturbed. We get two estimates, but these two estimates actually are missing the mark. They inherit one bias term in either of them. For the beta 0 estimate, the differentially private one for the slope, for the intercept, there's this term that has a magnitude and sign that depends on the x's, as well as the differential mechanism for x's. For the slope, we have a phenomenon that is reducing the estimated strength of association between x and y. And I think that is what Salil was showing with when you have a differentially private data and then you do the regression, there's a sort of a dampening of the slope over there. So, and this is definitely going to happen as long as you have a non-negligible amount of noise generated in there. And in addition to that, both of these differentially private estimates will suffer from inflated variance, which is to say they're not even getting at the right values that they're supposed to be concentrating at, and not to say that you can't possibly imagine that the confidence intervals that they are associated with from the naive method will be telling you the right thing either. And just to demonstrate, this is not showing up for some reason. There was supposed to be lots of ellipses that were drawn. Basically, what is showing over, this is going to, no. Basically, what's going on, we don't have coffee.
Was this a PDF file?
It was a PDF file, yes.
PDF should not have this problem.
But it does.
That's very helpful. Yeah, that's very helpful.
All right, maybe I should just, you would have to kind of use your imagination on this one. The orange one is obviously the true value that I use for the simulation. On the top left corner, I was meant to show you the correct ellipses, and they're just over repeated simulations. You're gonna see these ellipses, they're all gonna cover these. Oh, thank you, all right. Now this makes it marginally better, thank you. In the true case, if this is your truth, and then you had a well-specified model, the ellipses are pretty much centered over here. That's all fine. In the case where you have an epsilon that is, say, 0.2, this is where the truth is, and the ellipses are going to be centered over here. And they are going to be, on the one hand, overestimating the beta 0 and underestimating beta 1. And this is consistent over repeated simulations. The smaller the privacy budget, the further away these ellipses will move. So they will be missing the mark. It doesn't matter if you have a 95% quantification of error, you're not gonna get the right thing. So this is what, again, Salil was saying. If you deemed the original regression model to be adequate, when you just naively apply it to the differentially private data, chances are it's not adequate anymore. Only very occasional situations it will make it adequate, but usually it's not. So the right approach is, instead of using that still on the data, is to augment the model to include the fact that there was a Laplacian error injected into both x and y. And the most general situation, in the general kind of construction, without thinking about regression models, in general, what happens is this is a missing data setup. The raw ideal data will be integrated out in the way of deriving the observed likelihood. And what I want to show you, the two parts that comprise of the likelihood is the first part is the differential privacy mechanism, and this is the original model. And you have integration over this missing D, which is the census data that was untouched, some kind of idealized version of that. And here is the magical part of DP again, is that previously, when we had any kind of disclosure avoidance system, this is still the formula you should be using to calculate, but we don't know what is this eta. Until now, this eta becomes transparent is something that we could actually specify. Now, this integral can be difficult to calculate, could be easy to calculate. That depends on the case-by-case basis of the original model, but at least until now, it become possible. And I think that is something we should recognize as really a great thing. I would imagine that these will not show up either, but these are, I wrote recently I wrote a paper and there was a method and I applied it to the situation. So, okay, so this is the epsilon over 2. So what happens when we actually incorporate the aspect of the differential privacy mechanism in there and made it as part of a model, you're going to see a shift of the ellipse towards this truth. It may or may not still cover, depends, but you're gonna see definitely the ellipse is getting a lot larger and it's shifting to the right direction. And this, I think, is something that needs to be done in general of all models that previously we thought of as being applied to noiseless free data. I'll leave you with a very select list of literature because we are tapping into the realms of really vast and developed literature on missing data. The book by Ruobin on the treatment of missing data, and in this particular case, differential privacy could be regarded as a missing completely at random or missing at random cases, depending on the kind of definition of differential privacy you have. Salil wrote papers to talk about the danger of not being able to incorporate into the model the correct missing data mechanism and what kind of impact this will do in the resulting inference. And there are a whole bunch of other things about the computation and how you might be able to think about this in terms of hierarchical modeling, misspecified models, and Bayesian model averaging. And lastly, almost orthogonally, everything should be done within mind the kind of robust estimation techniques that we have so far. And that's what I like to say.
Thank you, Ruobin. And next, we have Mark Hansen, who is a statistician who works in journalism school. So he's going to talk a bit about communication in this new world.
I'm going to have to stop having that seem so curious, like there's a statistician in a journalism school.
Analytical journalism?
So I thoroughly enjoyed the papers this morning, and I apologize, I'm mid-cold. I thoroughly enjoyed the papers this morning, and I want to thank the organizers for inviting me to be on this panel. I certainly don't belong on a panel of this caliber. But I'm here today as a computational journalist. I'm trained as a statistician, but I spend my time at Columbia helping our students in the J School add computation to their reporting practices. Journalists are classically the explainers of last resort for the public, and when our policies depend on complex mathematics or statistics or computation, journalists need to step up their game and start to work with the algorithms that are shaping how our world functions. We can invite the public to take part in complex technosocial questions. And so I'm here as someone who tries to explain to the public and to stakeholders how they can think about privacy and the census. And messaging about these questions is crucial now, given the state of trust in government, although I do remember a recent survey that put the Bureau just behind NASA, CDC, and Forestry in terms of trust. So I've been trying to help with tools for interpretation. The approach is not dissimilar from our first paper this morning, studying specific questions people have and operations people perform on census data and see how they vary with different choices of epsilon. At the J School, our approach has been to work with the code graciously provided by the Bureau, beautifully documented and a joy to work with, for 1940, creating many additional simulations beyond the 4 bundled with the software for each value of the privacy loss budget. The results lets users assess the variation across various geographies, deciding if the resulting tabulations they're interested in are too noisy for their needs. Our hope is that this approach might help inform how to involve more people in the process of setting the privacy loss budget. So the entire United States seemed somewhat overwhelming to us, and so my students, Timothy Jones, Alex Calderwood, and I sought to skinny it down a little. And also, as statisticians, we really needed to see the data, which in this case means its spatial context, especially given the hierarchical constraints that are inserted in the top-down algorithm. We decided to focus on Los Angeles. 1940s Los Angeles is a useful case study, given redlining that was taking place, the Japanese internment, and we were fortunate enough to get some assistance on at least a corner of the U.S., Los Angeles. John Logan of the Urban Transition HGIS project gave us shapefiles for LA's enumeration districts from 1940. Mind you, the map is still a little noisy, and we have a little work to do to clean it up, but this gives you a sense of it. This is IPUM's data on the left. It's a chloropleth map where the colors represent the percentage white in each enumeration district in LA. Moon, the scale runs from 0 to 1, 0 at the bottom, 1 at the top. 1 meaning a completely white enumeration district. Here is a close-up of the region just south of downtown. And then we ran the Bureau's code. So here are some differentially private versions. Differentially private versions of the data. Variations in these simulations are a little hard to read, so we can dig in a bit. Here are the tracks on the left that make up Venice, California. My partner happens to be there right now and keeps sending me pictures of how beautiful it is, so I thought, well, all right. Anyway, these are the tracks, and by the way, the shapefile from John has tracks in it, so we can recover that geography if need be. Anyway, these are the tracks that make up Venice. They're sort of different colors of blue on the left. So Moon, these different colors represent different tracks. And then on the right, we have the IPUM's data showing us the true distribution of percentage white for each of the enumeration districts in the tracks that make up Venice. In this case, the scale goes from 80% to 100% white. This kind of, and then here's a close-up of the range of variations that we've seen across Venice. This kind of noise is reminiscent of what we saw in our second presentation this morning. We also saw some of what the speaker referred to as barbell distributions, things pivoting back and forth. I hasten to add that these are all with the most extreme value of epsilon that the Bureau published. That was the value of epsilon of 0.25. I chose it not to be alarmist, but to illustrate the kind of spatial analysis that we can perform. I'm pretty confident that we won't see a value of epsilon like this in 2020, but I don't know. I wanted to illustrate how narrative can shift depending upon the differentially private draw that we have, and how having replicates can help people using the data assess whether a noise level makes their data fit for use. We can adjust epsilon and see when the variation is something they can live with, given the competing benefits of privacy. Compiling a list like this, rather than, say, apocryphal stories about emergency management near the coasts, this is how we get the public and stakeholders involved in in helping to set important values like epsilon for these social technical systems. All right, I will stop there and thank our speakers this morning and the organizers of the conference. Thank you.
Thanks, Mark. And for our last speaker, we have Paul Ohm, who is an attorney from Georgetown University, talking about privacy issues.
It's really wonderful to be here. I will say that starting with that first panel, I was so glad I got to see a little more of the context and how we're here at the birth of what I think could be a really significant undertaking. So I applaud those of you who are helping bring to life the Harvard Data Science Review. And it seems like it's an auspicious occasion at the end of my 7 minutes to try and ruminate a little bit on what we've seen today and how it might apply to the launch of what is really a new interdisciplinary venture. I was so thrilled to be invited because I am a kind of interloper and outsider. I am a computer programmer and computer scientist. I was also a member of a government commission called the Commission on Evidence-Based Policymaking. So I know far too much about a lot of these questions to be dangerous, and that's really the theme of my talk, that I am dangerous, and you need to understand that. And so one of the things that happened to me during these talks was a light bulb turned on that I expect will happen for a lot of other people, because I work a lot with Kobe Neeson, and I've talked a lot over the years with Cynthia Dwork. And like a lot of the people in this room, I imagine differential privacy has always kind of stayed in the part of your brain that is tickled by the theoretical and the abstract. And today, for the first time, it gravitated to the other part of my brain, which is kind of deep in the firmament and is concrete and is practical. And I think that's a really important shift. But what you need to understand is the rate of change and technology diffusion to the non-technological world is absurd when it comes to differential privacy. I mean, we ought to study why every privacy lawyer in Washington, D.C., and there are hundreds, knew the phrase differential privacy 4 or 5 years ago. Or if you asked them what it meant, they wouldn't have been able to speak intelligently about it, but they knew it was important. They knew they had to talk to their clients about thinking about it. They knew that it would help them in conversations with regulators. And so because we're witnessing this rapid diffusion from what you do to what I do, I think you need to think really hard about the kind of messages and framing and rhetoric and graphics that you're using. And so I'm really happy to go after a journalist who's thinking about these very questions. So the most important thing I want you to take from this is congratulations. This is really important, interesting work. And I think these 3 studies will resonate and be talked about, including by people who have no idea what they're talking about. So let me then make 2 kind of micro points that occurred to me, and then I'm going to try and end with this larger theme about what we're doing here today. Okay, so smaller theme 1 is, this speaks a lot to something I think a lot about, which is the need for epistemic humility, to kind of admit what we know and don't know. And to me, the kind of signal example of this was the lovely talk and slides by Brad, I believe it was, where we have these beautiful kind of county maps that really, in kind of a glance, told the story in the way that Mark was just talking about. And they seemed concrete, and they seemed absolute, and they seemed like they were really a reflection on what differential privacy does to this abstract thing called ground truth. But of course, they came 4 slides after the slide that said, oh, by the way, there is no ground truth. And it was kind of played in the room as a little bit of a light moment. But of course, that's the entire game, isn't it? That if what you're trying to do is convince people who don't understand your lingo that differential privacy is doing X to the ground truth, You have to be really, really careful if you really believe that. And if not, if you think that there really is this kind of fundamental boundary layer below which you really don't know what you don't know, you have to be really honest about that at the outset, because if people find out about that later, it's not going to be good. Okay, so that's micro point number one. Micro point number two was inspired by Quentin's thought. Really interesting talk about the American Indian Alaska Native piece. And of course, my policy-making brain immediately went to, is this good for this cohort, or is this bad for this cohort? And the answer is it's both, right? It depends on whether you think the data analysis that would otherwise be done on these people is for good or for evil. And we're in a room where your mind immediately goes to good, right? That everything that everyone in this room wants to do is in the service of good, or at least tenure, right? Which aren't the same thing, I must remind you. And so it's important to understand that you need to start thinking about the answer to whether this is good or whether this is bad. And you need to start thinking like adversaries will in the political system who want to rush toward one conclusion or another. So let's do a quick thought experiment. This will lead me to my big point. Here's how I'm going to summarize to this morning's papers when I talk to friends. Differential privacy is terrible for African Americans. Okay, let that soak in. Now, reflect on the emotions that you're feeling right now, right? Emotion number one is, who is this idiot? He didn't understand any of the papers that we just heard. And then you've got this deep voice inside that says, okay, wait, I can think of a way of characterizing that work where that's actually a defensible statement. And then number three, oh God, if that's what lawyers think is happening with this work, what's going to happen to my research and grant stream, right? And number four, why all of a sudden do I feel when I'm thinking about discipline like I do when I think about Donald Trump? The analogy makes sense, right? We are living in a kind of hyper-politicized world where we are locked in deep battles about right and wrong and true and false, and we're asking questions that we never have. And so Ori set up this part of my talk beautifully, because this brings us to the question of who sets epsilon. And Ori gave an account that I've heard many, many times, which is, what was the phrase you kept using? You kept saying, society needs to do that. Guess what? Your society, the people in this room, have to be active participants in the conversation about good and bad, right and wrong, privacy and utility. And here's the worst part that you're going to hate. That's going to be a political enterprise. You are all political actors who are engaged in politics. And whether or not you want to think that that has something to do with your discipline or doesn't, you've always been part of a political conversation. You just don't know it, and you don't make those moves. I'm being a little too general. I'm sure some of you know it, but many of you don't. Many of you think it's not for me to dirty my hands with the policy piece. And I'm here to tell you, if it's not you, it's going to be someone worse than you. And it's going to be someone who doesn't understand this at the level you do. And so you need to think about framing and rhetoric and communication and policy. One thing you can say about the Census Bureau, and by the way, I haven't said it yet, this is a heroic act by a government agency to advance the state of the art of something like differential privacy through sheer will of kind of non-political staff exertion. It's crazy. But you should understand that what the Census Bureau is doing is lawmaking. And when they decide to use differential privacy, they are forming law. And someday when they decide to set epsilon, they will be making law. And the Hamiltons and the Madisons who are going to be part of that lawmaking hopefully will include some of you in this room, but you're going to have to be willing to kind of relinquish the neutrality that you've been brought up on since you were a baby grad student and understand that you're part of a political fight now. All right, thank you.
Thank you, Paul. Well, I had a set of questions, but many of them have been somewhat addressed. So I think what I want to do now is actually go to audience Q&A. What I'm going to do is collect 4 or 5 questions at a time, and then turn them over to the panel to address whatever subset, to react to the comments and questions that they've heard. Okay, so who wants to start? All right. Let's see. You want to wait for the mic, please?
My name is Andrew Beveridge. I've been working with census data since 1970, and I'm on the New York state complete count commission, not that we've done very much. And I'm also work in redistricting, and when I teach about the census to my students, I tell them that their census is about two things, money and power. And it's really to allocate money and power. And so the question that I have about the advent of differential privacy is really related to those two things, and most particularly, how is it going to affect the redistricting, which is in many ways one of its main use cases. And so that's really, and I'm very concerned about that.
Okay, thank you. Another question. There we go. We have one here.
Yes, this is a question part for the US, well, for the previous talks in the morning, but I wonder what the panel would think about that. So if once the census decides on an epsilon and releases the data, no matter what epsilon is decided, there will be a privacy loss. And are they planning to do re-identification attacks to simulate? Would it be easy to re-identify any individuals? And if so, are they planning? Should they plan to publish the re-identification rate? And the third part of it is what would happen if, I mean, given that probably other computer science would think we need to see if we can attack, we can re-identify the release. What would be the action, or what should be the action if a re-identification is found after the data is released?
Okay. I will turn to my panel in terms of what advice would you give to the census on those questions, since we don't have census right here. Thanks. Any other question? There's one.
My name is Hiro Minato from U.S. Energy Information Administration.
Louder.
In the survey literature, there's a total survey error framework, and I guess the census could be part of, maybe total census error, right? Echo framework that, and so the differential, like infusing the error to it, could be part of like a measurement error, part of the survey, total survey error framework. And I wonder how you might actually quantify or to like put in all the whole framework, and maybe in addition to the error, you can think of like total survey risk as if you are thinking of disclosure of the risk. And I wonder if anybody can kind of brush stroke of like framework for us to, all to be able to kind of move forward this discipline. And I really think the differential privacy is an excellent quantifying risk, quantifying uncertainty is one thing, but I think someone just comment on that would be great.
Maybe one more? Okay, yeah.
This is Simpson Garfinkel, U.S. Census Bureau. The primary difference between the first set of speakers today and the second was the first set of speakers presented quantified use cases for accuracy. But the second panel did not present any quantified use cases for privacy. We need quantified use cases for privacy. And so I challenge everybody here to come up with them and to do data analysis to see, for example, what is the added cost to an adversary using census data to inflict a social harm or to single out vulnerable populations. We heard that it can be used to cause people to have their Section 8 housing to be denied, but let's quantify that. Thank you.
Okay, so we've got 4 questions. One having to do with impact on redistricting. The second, will the census publish re-identification rates? The third one about total survey error, how this fits into the total survey error. And then finally, what would quantified use cases for privacy look like? Does anybody want to start with one of those or more? Salil.
I'll start with the last question by Simpson. I agree with Simpson that having studies that are really digging into the significance of the vulnerabilities and what the impact might be on people are important. I just, rather than having much of an answer for Simpson, I wanted to add to that, that as we think about future conversations here, I think one thing that that we don't have in the speakers and panelists today are people speaking for the effort in getting out the count and the impact that having a story about the Census Bureau modernizing its disclosure avoidance will have on that, and that's something else that also potentially could be quantified. And we can think about that as, compensating for one of the other sources of error that always exists in census data.
Other comments?
Could I just add a little bit at this last point? I mean, there are efforts which Simpson knows about, right, which using the soon-to-be-released 2010, sorry, I guess, is it on? Okay. There are other efforts that are a release of data and encouragement of users to look at these same tables with the 2010 data. There we won't, because of the legal restrictions, won't know the, quote, truth data, but that's coming out soon. And National Academy of Sciences, in particular the Committee on National Statistics, will be holding a workshop to look at some of those use cases. I would, in early December, and I'm the chair of the planning, or co-chair of the planning committee for that effort. But I would also note this is not such an easy thing to do, right? In terms of the breadth of uses that some of this data is used for, makes it really difficult. I think that so the use cases here, and the Census Bureau has attempted through the Federal Register to try to collect those use cases with difficulty. And I think understandable difficulty in retrospect, because we really they vary, right? The examples here I think are good ones of the segregation, right? Because they're particularly sensitive, right, to exactly the set of issues which we think we know. So I guess I would urge, and you think about those use cases, that's way to think about it, right? I mean, while that's, leaning against the wind, and it could be nice to know that, it works well in a bunch of examples, I think the problem is going to be, and where we need to focus our attention is on those cases where we think the vulnerabilities are likely to be there, right? The sensitivities are likely to be there. The solution may not be changing just the epsilon, right? It may be other things that's been discussed today, but understanding those cases where this noise is going to matter, right, it seems to me where I would put my attention.
I mean, briefly, no one's addressed the re-identification study question. I mean, I certainly, as an outsider, would encourage Census to ask that question and share the answers with us, because it will fill in an important missing piece and question we've always had about epsilon and differential privacy. On Simpson's question, I think it's directly in conversation with what I was trying to say. I understand why you want quantified threat models and things that can be measured. I'm not sure this political process here inside will be patient enough for that. And I'm not even sure that's wrong, right? Because the world of policy isn't always measured numerically. And so, for example, we have the Equal Protection Clause of the United States Constitution, which says we don't treat African Americans differently than we treat Caucasians. And I guess there is a quantified response to that if differential privacy is shown to have some disparate impact based on race, but the courts may not demand that. The courts may look at different colored charts and say that feels like an equal protection violation to me. So I guess that's my point. And as you're moving into a political realm, which again I'm sure you don't want to do, there are different ground rules, and demanding quantified proof is your ground rules, but I'm not sure it applies everywhere, right?
I like the money and power question, and I don't know the answer, but I started slowly and now like snowballing, trying to understand how redistricting works as it is without differential privacy. And I had a number of very, very simple questions about boundaries and so on and so forth. And what has astonished me is how even those of you in this room who helped me to try to answer those questions, I have found contradictions from legal experts for everything I've been told. So I think this is extremely important, and I think that we need to have at least a collection of strong people from a few different disciplines talking together to understand what's done, what could be done, what cannot be done, sort of both legally, and of course when you ask a lawyer or a law professor, can we do this? The answer is always, well, it depends. The court might find this, or they might find, I mean, Paul even just said that. So it's very difficult as a computer scientist to try to nail down the ground rules for trying to find a solution. We seem to have to handle many different versions of the problem. But I'm not even convinced that the different numbers, the way that there's a different impact in terms of population estimates when you're measuring fractions, I don't even know whether that harms or hurts existing methods. So I found an example of one case where the court sort of said, well, if this district is not a majority-minority district, then we do not have to apply whatever it was that was being considered. So in that situation, a slight overestimate might have helped rather than hurt. And in general, differential privacy does bias very small counts up to some extent. Things that would have been rounded to zero, things that when you add the noise symmetrically would have given you a negative number get rounded to zero, they get rounded up. So I don't even know what the impact of the current techniques would be on the current redistricting because I don't understand the law enough. So I think this is a very, very rich and important area of conversation.
And part of the subject for the after lunch session. Anyway, more questions?
So on the issue of, what does epsilon mean? McClure and Reiter have shown pretty clearly that epsilon is not a measure of disclosure risk, and that you can have high epsilons with low disclosure risk and vice versa. And, the problem is that disclosure risk has been here greatly exaggerated. We still have no documented case of anyone's identity being identified by anybody outside of the Census Bureau in any Census Bureau data product, even though we've had decades and decades and decades of data. And Ron Jarman acknowledged the fact, the deputy director of the Census Bureau, that this Reconstruction exercise and re-identification, nobody outside the Census Bureau, he said, could possibly confirm whether or not they had successfully identified anybody. So, and suppose they did. We've got 6 variables on the census, all of them on the decennial census, all of them are things that are effectively public, widely known about everybody. And so the question is, really, is it worth destroying the data that we use for planning and social science for a chimerical threat?
Okay. Another question there.
I think Steve is touching on a broader point, which is that for social science and for computer science, the risk of threat is a different beast. And if you're in computer science, and I'm not saying, I'm speaking in generalities, and I know that this is, simpler than it is in reality, but the threat is to recovering a database, recovering a system. And to social science, that's not the threat. The threat is the product of recovering the system, the database, times the harm that could cause. And that's, I think, what Simpson is at in terms of quantifying that risk. We don't know how to do that yet, because that risk, and this is where the law comes in, that risk is hard to quantify because there's so much uncertainty on so many parameters that no one discipline has a great grasp on. But that's what we really need to be thinking about. It's not the harm that you can recover a database, it's the harm that someone can do with that, and how do we quantify that?
Any other questions? There's one.
I have one more question. So I guess one recurring theme here in the discussion was about quantification of uncertainty and understanding the extent which we can sort of use quantities or estimates reliably. And this is brought to the fore when in these discussions of differential privacy, but as sort of came up a few times, it's present even without differential privacy, and it's certainly present when you start doing some of the older disclosure avoidance techniques like cell suppression and stuff. And so I guess my question, to turn this into a question, to what extent does this kind of bringing the uncertainty of these numbers to the fore change the way we discuss the way these statistics are used publicly? And is this kind of just a small instance of a possibly more fundamental shift, given the way, as Paul said, politics work? How do we have good evidence-based policy making? It seems like uncertainty quantification seems necessary for that, but it also seems to make it much harder given the fact that it complicates the kind of politics and the discussions. And so I'm just curious to know, is this a more fundamental shift that's going on here that's really much more than differential privacy?
Right. Okay. So I think I'm going to summarize the first two questions as basically saying, asking everybody here to think about what advice could you give to census or researchers to quantify harm from disclosure, and also to measure where society is on the trade-off between privacy and accuracy. And then the second question, I think, is also really interesting. How does this change, how do we increase reliance on evidence without overstating how certain we are about any evidence produced, while accurately representing the strength of the evidence that we have? Okay. Yes.
So as economists, what we do, our business is making trade-offs and trying to quantify them and, bring the marginal cost to the point where it equals the marginal benefit, and that's the happy spot where we want to be. It's not true that we just multiply the threat by the cost. We also need to multiply it by the probability of the threat. And that relates to what I said before, that with the epsilon differential privacy notion, I guess we realized at some point that quantifying the probability of the threat is just too much to expect, so we will come up with a worst case scenario guarantee, and we don't need to model the probability that happens. We just guarantee against the worst that could happen with positive support. That may be the way to go, and again, right now, that's the only way to go we know of. But that is very different from what economists usually do. So I think computer scientists are used to work with worst-case scenarios and to prove theorems about bounds. For economists, we never talk about a worst-case scenario. If it's a zero measure or zero probability, low probability worst case, we don't care about it. We care about where the mass of the distribution is. this relates to what I said before about the asymmetry. So what we saw today, this morning, was distributions, and we looked at the bells and we thought, okay, most of the points are here, so it seems fine. We never said, wait, but there is one point there where the worst case scenario is, because it was unlikely that we will be at that point. That's on the usability side. On the privacy side, however, we keep being stuck, for better and for worse, with a worst case scenario as unlikely as it may be. And so I think that a lot of these exercises that, let me say another thing. Part of this is so exciting for economists because I think that we, in the second half of the 20th century, we started moving away from markets where you sell tomatoes and apples and pears, and we had all of a sudden in the 60s and 70s economics of knowledge, economics of information, these new goods that we started working with, asking what's the value, what's the how to price them, how to trade them. They don't behave like tomatoes and apples. Now I think there is a new thing, newish, economics of privacy. So how do you work with that? How do you model, how do you put in the utility function a term maybe that represents the cost of somebody finding out my sex and age and race or so. In a way, we want to start doing that. We have this new thing, privacy, and we want to put it into economic theory and find tools to work with it. But we're stuck with this notion that we finally can quantify it, but it's a worst case quantification that is not natural for us to work with.
We're running out of time, but if somebody has something burning that they want to say quickly. Okay, real quickly, okay. We can maybe go. Okay.
I think it's wonderful if there haven't been big privacy compromises in the past, but one thing that I've learned in the cryptographic world is that adversaries really are there. They're there, they do it because they can do it from their computer and they can have fun, and they're there because they've been paid to do it, and they're there because they think that maybe by finding some stuff out, they might have some edge and they can blackmail you or coerce you in some other way. And I was actually very serious about Palantir. Dana Boyd speaks about Palantir having contracts with local governments to, well, I don't know what exactly, but something having to do with Section 8 housing. So even like decades ago when we were using computational methods for fighting spam, and people said, oh, but really, there's not so much, blah, blah, blah. And Udi Mamber, who at the time was at, well, that's not, anyway, he said, PhD level research we see for this, okay? That adversaries are out there and they compute and they take resources and deploy them for their adversarial goals.
Great. Anyone else?
I'll just add a little bit on the matter about sort of this uncertainty question. I think this is really an important issue going forward, and that's a process that might go, as Ruobin suggested before, I think she did, putting air bands around sort of estimates that we have so we kind of better understand that. Part of that's going to take an education of the public. Part of it's going to be, sort of educating people to, how to deal with uncertainty. The analogous problem, it seems to me, is in the medical field, right, where, for a long time, doctors told you, this is what you have. This is what your treatment should be, right? And we have had this process now where, there's a greater provision of information about the risks that you actually face. Sometimes, risks which are extraordinarily low and people have a difficult time sort of, dealing with those. We know from human nature a good deal about that. So this isn't going to be an easy task, but it does strike me that it's one we really have to embark on. People need to know the uncertainty, the ambiguity of results that they face, and somehow we've got to start making that part of the public's knowledge, decision makers' knowledge, and starting to get comfortable with it. Oh, sorry.
Just following on the discussions of sort of risk versus harm. The comments of Ori and audience that and Brad and others that epsilon is not a measure of harm are right, but it is an upper bound on disclosure risk. But I think the less important thing is not epsilon, the value of epsilon itself, but the move to being disciplined about what are unavoidable choices. And in the end, even though differential privacy is a worst case guarantee, the fact is, we heard this morning, the Census Bureau was able to reconstruct a quite large percentage of the individual level responses. And now it's obviously not for computer scientists on their own to answer the question about what's the harm of that. We do worry. Paul's comment about differential privacy being bad for minority groups did make me very uncomfortable. And we do care very much about the impact of differential privacy on minority groups, on vulnerable groups. But it's very unclear how it will play out. It really depends on the way in which the data is used, and as we said, a lot of work needs to be done to use this data in the right way. We have to remember that there was all these sources of error in the data before, and also take into account, what is the benefit of modernized privacy protections, again, in making people comfortable in responding to the census.
I'll also quickly add to Adam's question about the uncertainty quantification. I absolutely agree with what Joe said, which is that whether you're not like it or not, the uncertainty was always there. It just previously we weren't able to even put it on concrete terms. Now that we actually do know how to do this properly, and I think this should be an excellent opportunity to educate. I obviously I have no idea how this, in terms of policy making, to what extent people are willing to now start to entertain distributions and ellipses and these things, but that's the right thing to do if we're, being very severe on ourselves. And we do now have tools, computation and models that we can use to illustrate, what is, if we're looking at, instead of the point estimate, but instead an interval, and look at, the upper and lower bound of the utility of doing a policy in this way versus the other to every, subpopulation of interest, then it is telling us still something, and I think it's telling us more than just having a single number.
Sorry, since we're trotting along. This discussion, my first brush with the census was when I was in graduate school, and it was the lawsuit of the 1990 census for adjustment. And I was working with a group from Berkeley, and it was the first time that I'd seen in my career as a student that sort of the titans of my field could disagree on something. So John Tukey and Feinberg were on one side, and I was working with David Friedman and Leo Breiman, there was this huge sort of rift about whether or not we should adjust the census, and could it be done in a reliable way, or are we just pushing noise around? And the Berkeley team was helping to establish that we're just simply pushing noise around. And at the end of it, I asked David Friedman, the gentleman I've been working with, my professor I've been working with, I'm like, after all of this, and after we've tried to take this all apart, there's clearly a problem. What would you do? And he says, I don't know. He says, nobody asked me, because his role was not to do that. And I think I've always carried that with me, that the role of the public intellectual, the role of us as part of a university is to maybe sort of deal with problems like this in a sort of constructive fashion.
Okay, well, thank you all, audience, for letting us eat into your lunch a little bit. And thank you to the panelists for your thoughts, your insights. I encourage everybody to read the bios that are on the website so that you know the background of everybody who's been talking to you today. And I look forward to seeing everybody back here at 2 o'clock to learn about redistricting and education on these topics. Join me in thanking the panel.
So bad for Jeff Larson.